Hi, welcome everyone. I'm very glad to be here and to be speaking here. I'm Mathis, and today I want to talk about the changing role of enterprise data science teams in the world of large language models. And what does that mean? Well, it means that with large language models, there came so many promises and there's so much potential to make information universally accessible and searchable, potential to increase process automation, kind of like steered by natural language, individual productivity gains if you think of programmers using AI to generate code. And that's one side of the coin. And the other side is that many enterprise data science teams actually struggle to adapt to this new world, to this new way where how they develop models or products really changed. And that's met with a lot of fear and insecurity as well, like what is expected of me, everything changed all of a sudden. I'm working on these natural language processing applications, on this language AI models, but how I work on these models has changed. And this is what I would like to talk about today. And first, I'm going to tell you what has actually changed with large language models and how we think about it at DeepSet and how I think about it. Then I want to share some of the pitfalls that teams building AI-enabled products might fall into, and there's a few traps along the way, and I'm going to share some of them. Next, I'll talk a little bit about the new skills that you need as an individual contributor, data scientist, but maybe also a software engineer working on language AI-enabled applications and products. And then I want to share how AI teams can actually be successful and not react with fear and insecurity to this new world of large language models, but actually become like kind of like product shipping machines who just successfully build products that drive value for the users and for the business. And then, of course, I'll have time for your questions, and I hope I can find some good answers to them. So first, let me start with a few words about myself and about the company that I work at. So I'm Mathis. I'm head of product at DeepSet. And what do we work on at DeepSet? Well, we have two products. One of them is DeepSet Cloud, and it allows AI teams building these LLM applications, these language-enabled, AI language-enabled products to solve a lot of the challenges I'll be talking about here today. So a lot of the organizational complexity, making data scientists talk to application development engineers, making them work together with end users or subject matter experts, involving product management and creating transparency throughout this whole process. And then we also have an open source framework called Haystack, which is a Python framework for individual developers looking to build NLP applications end-to-end, and it gives you all the components, the pieces that you need, and a nice abstraction over it so that you can build in a very scalable and reliable way. And this is fed by many people from our community using this framework for years, using it in production, using it for serious applications, and that's kind of been baked into the framework, so it's very much targeted at the developer who's more like an AI practitioner who really wants to deliver applications. All right, so let's get right into it. What time is it? I'd say it's time to ship, and the question, of course, is it's time to ship what? It's time to ship products. It's time to ship products that are supported by large language models and that can do things that people could have never thought of a year ago even. Agents independently resolving complex tasks like, okay, go fetch me the weather in London and then make me a packing list for my trip to the London AI Summit, things like that. But of course, if you scale it up, there's so many great applications that you could build with this technology. And why is it actually time to ship now when you look at this technology? Well, I think what has fundamentally changed, some might say, with the rise of ChatGPT is that if you think 1 or 2 years back, actually building a model that had the capabilities that you needed for your product, like an embedding model, vectorizing your data to perform semantic similarity search, or a model generating answers in a chatbot, you really needed a dedicated team of very intelligent, very smart people, research scientists, machine learning engineers. You needed infrastructure, you needed data, and as a consequence, this technology was really only open to a very few select companies. Not everyone could attract the talent, not everyone had the skills, not everyone had the data and the infrastructure to build these models, to build them from scratch, to train custom algorithms. And what's changed with ChatGPT is models, they just became a commodity. It's now something that you can go out and buy. You can go to OpenAI, get your GPT-4 subscription, and then just use it in your product. You can go to Cohere, to Anthropic, you can go to Google, and these models, they exhibit incredible performance across many tasks and domains. You have GPT-4 beating out high school students in many standardized tests. You have Palm 2 from Google actually passing medical tests for doctors who want to become doctors, and actually passing that, getting a passing grade. So this is something that you couldn't even think of a year or 2 years ago. And for teams building AI-enabled products, and more specifically for data science teams, this means a shift in their mindset, because they used to build models. So the process was, okay, we have this challenge and we want to use AI. Okay, let's get the data science team involved. They go away, they train a model, they iterate, they do that for half a year even maybe, and then they throw it over the fence to the software engineering team, to the DevOps engineers, the MLOps engineers, and they need to integrate it into the product. And then at some point, end users get involved and they get to interact with this new AI-enabled functionality for the first time. And really, this has changed. This model building step, it's become so much faster, whereas it took like months, years even before. Now it's like days or weeks. So what's expected of a data science team is pretty much, okay, you ship that prototype like a real product that end users can use within a day or 2 or a week, and then you test it, you iterate on this. And this really is something that teams need to adapt to, and also the structure of the teams probably needs to change a little bit. If you're setting out to build AI-enabled products, language AI-enabled products, there's a few traps that you might fall into, and I want to share one of them here just because I see it happening so often with some of our customers, for some people in the community of our open source framework, but also when I give talks and webinars, this comes up again and again. And I call it the analysis paralysis trap. And what many teams do on model selection, for example, is they wait and they agonize and they say, should we pick this one or that one? And why do you pick a model? So basically you have your product, you want to provide some functionality that needs AI, that needs a large language model, and but that's only part of your product. And teams start to focus on that model exclusively. They don't think about their application end to end. They only think about the modeling part. And what happens is that they spend weeks reading benchmarks, reading a paper, reading that, but this has like 2% more accuracy than that one, and this one is, and that's not a point. The model is just a component of your system. It's just something that you try out that you can swap easily. Of course, you shouldn't go and sign like a 5-year contract with OpenAI and then you're locked into that, and then that's the only model that you can use. But instead what you're going to do is just pick a model that seems suitable, that's easy to integrate, and start and build your application end to end. deliver it to end users, test it with subject matter experts in your company, and then you actually know where it falls short, you know where it excels, you know what type of applications your users expect. So really don't spend that much time on model selection. And another variety on that same trap basically is vector databases. So vector databases are something relatively new, and there's a lot of them around now. And why do you need them? If you're building a product for search in the broadest sense, let's say you have your company and you build machines and you have long manuals for service technicians, and these manuals can be thousands of pages long, and they want to identify quickly what they're looking for. They want to basically get a search window up and then search instead of reading through these manuals. And what you're going to do if you want to build that with AI is you vectorize the text, you vectorize the service manuals, and you embed them into vector space. And then, of course, you need to store these vectors somewhere, and this is where the vector database comes in. And when your question comes in from the service technician, you will vectorize that as well, and then you can perform some fancy vector math, and you will find semantic similarity. And very often when I give a talk or a webinar, one of the questions I'm almost guaranteed to get is, so what vector DB would you recommend? And this question really puzzles me because, I mean, of course, there's a bunch of them. Like there's Pinecone, there's Quadrant, there's Elasticsearch, and all of them have different qualities, but really it's about your use case and not some general recommendation. And people ask this question before even figuring out their use case. So they say, yeah, but this one is a bit faster, and this one has that feature that the other one doesn't have, and they haven't even figured out their full application. And that's just wasting your time at that stage. So again, the same as for model, treat the vector database as a swappable infrastructure component. Software engineering has gone a long way. There's nice abstractions around everything, and you can just swap them out at a later stage if you realize, oh, well, that doesn't work so much, or, oh, we really need that sub 100 milliseconds response time because it's critical for our use case, and then you find the vector DB that supports the other features you need and gives you that. So really start building instead of agonizing over these implementation details of your application. I now want to get into the skills that you need to build with these large language models. Some of them you always needed. Some of them are a bit new-ish, but I think they're not, right now they're not basically combined in a single persona. And if you want to build with that, you might want to acquire some skills and think about that. So the first one is that if you're a data scientist, you know a whole lot. You know about algorithms, you know about quantitative evaluation of models, you know how these models work, you know your metrics, and you know how to interpret them. And what your task is going to be in a team, building with others, being co-located with application development engineers, back-end engineers, front-end engineers, product people, even designers maybe, is you need to bring these skills to the table, you need to teach them, and what you're going to learn is you're going to learn the latest and greatest best practices on software engineering, building a reliable service, something that is scalable, that fulfills multiple requirements like, okay, we have a speed and we have an accuracy, and we have a trade-off between those maybe, and how to build a CI/CD pipeline, testing your application so that it runs well and is stable and observable as well. So this is what you're going to learn and bring to a team, and then you learn that from the team. And on the more individual level, one thing that is really core, I think, is thinking in systems. So these new AI-enabled services, they are usually heavily distributed systems where you're using many different services, like microservices. You have a model, an inference server maybe, and these systems are complex and they work a bit differently than if everything is in one kind of application. So you really need to think about that, think about the impact, think about asynchronous workflows, synchronous workflows. That's a core component, definitely. Then, of course, you need your basic machine learning literacy. You should know your train test split. You should know how to evaluate a model. And that's just the basics, and you still need it. And then this is maybe a bit something that came with large language models, one of them definitely. Now you will also need to be well versed in more qualitative and maybe even explorative methods. So prompt engineering comes to mind, observing users, digging into single data points, doing user interviews maybe even. And if you look at prompt engineering more specifically, some people say, well, that's a new discipline of engineering. I would say, well, it's kind of a skill that you need as a data scientist, but also maybe as a backend engineer working on LLM-enabled applications. But then it's more play, it's more art, it's more exploring, because it's deeply qualitative. You try out a prompt and then you look at the result. And what you need to do is you need to talk to your users. You need to know what do they want. Maybe you're a clothing retailer and you have like an online shop and you want to have a shopping assistant, and that shopping assistant should have your brand voice. And you actually need to figure that out with the prompt, playing with the with different prompts, then test it with the users, see if they react better to this voice or that voice. It's not about, oh, there's this single metric and we can look at it and then we're done. It's more a triangulation of methods, really. And when you go to the level of teams, so how to be successful as a team building LLM-enabled applications, well, I'd say you want to have product teams, not data teams. You don't want to have this separation between the data science team and the application development team. If you look at modern software development, basically they moved to this holy trinity team of product engineering and design a decade ago. And what you really want to do is, okay, data is just a part of this product and we need it, and we pull our data scientists into the team. Maybe even you don't need a data scientist, maybe it's a smaller part of your application. Some developer in your team is NLP savvy and they can fulfill that role. So really get these teams into product teams who build products. They're not building data, they're not building models, they're delivering products to end users. And the next one is, how does your actual software development lifecycle look like then? Well, it looks awfully similar to basically the classic software development lifecycle, which is you have your team discovering the user needs. You can interview users, you can look at the market, you can look at metrics that you track in your product. You discover what do they need, what are the features they need, how can we bring value to them. And then you explore solutions. You figure out, okay, this would be valuable, but it's not feasible for our business, so maybe let's change that a little bit. And you find that sweet spot where you drive value for your users and your business. And you do that together in the team. So data, product, engineering, and design, do it together in the team. And then you go and implement that, and once you implemented it, you ship it and you test it with the real users and you iterate. So this cycle is something that is probably happening in like a 2 to 6 weeks window. You're actually shipping your AI-enabled functionality with all your other product features. You can implement it in a single sprint, and then you test. You do a small step, you test it with the users, and then you can change what needs to be changed. And that's in essence like how I'd see how to build AI-enabled applications in the world of large language models. And everything on the single slide, to sum it up, models are a commodity, go out, buy them, don't agonize over implementation details, start building now, skill up on prompt engineering, on qualitative methods, co-locate your team, and then build in an agile, iterative fashion, and really get something out to real users. And now, time for questions, of course. One second, I think we have a microphone. No, I think also we have a microphone, so then.
Do you think there's a difference between a data science and a software engineer?
I think, of course, they came up differently. They might have many different skills. And usually software engineers, they're more used to building these applications. Data scientists, they work depending on the discipline as well. I mean, I'm talking about language. Somebody who works with sensor data might be a very different data scientist, but they're heavier on the statistics, on the modeling. But I think they're getting closer together with these new modeling capabilities.
Hi. Maybe slightly more sort of technical question around, I guess, large language model evaluation methods. So we have been reading a bit, and I think some opinions of are actually using, say, like a evaluation, an LLM to evaluate cohesion and etc. So then my question will be, like, how do you make sure that evaluation LLM is also behaving the way you want it to be? But yeah, just your take on that.
Yeah, so that's actually something that we've also been exploring. So how do you actually evaluate these responses that a large language model gives? Because many of the traditional metrics are not suitable. So you have your F1 score, for example, in question answering, which looks at the word overlap. That's not suitable to evaluate a large language model response. And what we think is, and what we've been having success with now, is actually using a kind of a hybrid approach. Again, this triangulation. So we have model-based evaluators. One of them, for example, a hallucination evaluator, which detects if a model made something up. In our case, it's for retrieval augmented generation. So you have supporting documents, and it looks, is everything that the model generated supported by these facts, by these documents? And if not, it flags that. And you can look at that, of course, but then you also want to get your user feedback in and actually see how it performs against them. You can look at click metrics as well, like get other metrics in and see how it performs for your use case. It's not about being scientifically exact, like that's the old data science word. You're trying to build a model that works for your users, or a product that works for your users, so evaluate it with your users, basically.